Good morning, class. So, as you can see, we'll be starting our lecture this morning. So, the topic we are treating is measures of central tendency and dispersion. So, before we go through that, I will walk us through the behavioral objective of this course. At the end of this lesson, as a student, you should be able to at least number one, define statistic, compute the mean, media, and mode of ungrouped data. Explain the meaning of dispersion, define and calculate range, variance, and standard deviation of ungrouped data. Explain grouped figure. Define class, interval, class boundaries, and class mark. So, without further ado, let's dive into the main work. Meaning of statistic. Statistic is the branch of mathematics that deals with the collection, organization, presentation, analysis and interpretation of numerical data. Measures of central tendency. Measures of central tendency are values used to represent the center or average of a set of data. They include mean, median, and mode. So let's do some examples on mean, median, and mode, and at least define it to know the meaning. What is mean or average? Is obtained by adding all the observations together and dividing by the number of observations. Here is the formula. S bar is equal to summation S over N, where S bar is equal to the mean, where summation S is sum of the observations and N is the number of observations. So example 1, let's find the mean of this data. We have 4, 7, 2, 5, 9, 2, 6, 5, 3, and 8. Sum of the datas, which means the addition of all the datas. So let's begin by doing this. 4 plus 7 plus 2 plus 5 plus 9 plus 2 plus 6 plus 5 plus 3 and plus 8. When you add up everything, it will sum up to 51. Number of observations, you count it one after the other. Those are the data given: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you can see, you see that we have 10 observations. So with the definition we've given earlier about on mean, we say mean is the addition, which is summation of the observations over the number of observation. So the summation of the observation is 51. That is addition of all the observation, all the data given, and the number of the data given is 10. So by doing so, mean, which is S bar, is equal to 51 divided by 10. Our mean is 5.1 mean. So let's move to media. The media is the middle value when data are arranged in ascending or descending order. Please note the ascending or descending order. So the mean media of a data is majorly the middle of the selected data, the data we are working on. You are going to choose the middle, that is the one right at the middle, dividing it into two equal parts. So by doing this, we have formula which makes us easier for us. For odd number of values, here is the formula for media. Media is equal to n plus 1 over 2 nth term. For even numbers of value, media is equal to average of the two middle values. Example for us to treat calculations involving media. So let's take this 4 as the data: 4, 7, 2, 5, 9, 2, 6, 5, 3, and 8. As you can see, there are 10 values, which means we are having even number here. The middle term, as you can see that the value must be arranged in ascending or descending order. As I've said earlier, that you should note that ascending or descending order. So here we rearrange this data in the ascending order. which means from the lower to the higher. When you are descending, you start from the higher to the lower. So if you are picking from the lower to the highest number here, we pick from 2, we have 2, we have another 2, we have another 3, we have 4, we have 5, we have another 5, we have 6, we have 7, we have 8, and 9. So if we count and choose the middle number, we see that we can't fall to the right, to the left, we can't fall to the right. We are left with 5, 5, which are the two numbers which remains in the middle. So there are 10 values. Even number, as I've said earlier, the fifth one is 10, the sixth one is 5. So adding them together to get your media, 5 plus 5, which is 10 divided by 2, is equal to 5. 5 is the media of this data. So the mode, what is mode? The mode is the value occurring most frequently. That's the most occurring number, most occurring data within the given data. So let's, for instance, in this data given 4725926538, frequency, we have 2 appears 2 times, we have 5 appears 2 times. Both have highest frequency. Mode is equal to 2 and 5. This is called bimodal data. Data that has two mode. Data that has two mode is called bimodal data. So let's move on to measures of dispersion. What is dispersion? When I'm teaching, I don't just teach for fun, or I try my possible to make sure that student gets the meaning of what they are about to learn. So we measure dispersion. Before we even measure dispersion, let's think of the definition of that dispersion. What is it? Dispersion is the degree of which data values spread from the central value. Measures of dispersion include the range, the variance, and the standard deviation. Let's take it again. Dispersion is the degree of which data value spread from the central value. Now, to continue with that, we have to know that to do calculation on dispersion, which are the measures of dispersion, we have to know some things, which include the range, the variance, and the standard deviation. So let's begin with the range. Range is the difference between the highest and the lowest value. That is, when you subtract the highest data minus the lowest data, you have the range of the value given. So now, from this, the formula of range is equal to highest value minus lowest value. From the data given, we have 9. We are using the other example that we used earlier to calculate our mode. We have 9, which is the highest value in this data, and we have 2, which appears to be the lowest value in this data. So the range is equal to 9 minus 2, which is equal to 7. Variance. Variance measures how far data value deviates from the mean. How far data value deviates from the mean. We've calculated the mean earlier, which happens to be, that should be 5.1, the mean. So we want to see how far data values deviate from this mean. So from the formula, the variance is equal to Tyndall square, which is equal to summation s minus mean close bracket square over n. So the data we are using earlier is this. We have calculated the mean, which happens to be 5.1. So these are the data s. These are the data given. This is it. So here is x minus s bar, which is the mean. 4 minus 5.1, you get this. 7 minus 5.1, you get this. 2 minus 5.1, you get this. 5 minus 5.1, you get this. Then we square this, the value that we have here. Minus 1.1 square, you have 1.21. You can do it, compute it from your side and see how it goes. So with that, from the formula, we have summation of the square deviation. This is what we want to use according to the formula. The summation of this, you add up all this, then over n, which happens to be 10. So sum of square deviation is equal to this. Variance is equal to 68.90 divided by 10, which is equal to 6.89. That is the variance. Standard deviation. Standard deviation is the square root of variance. The square root of variance, which means once you know the formula for variance, you'll be less bothered about the formula of standard deviation. All you just have to do is to square root both sides. By squaring it both sides, you have your standard deviation, which is equal to this, the square root of a variance. So what is the formula of variance? You know it already. And how? We've calculated variance. All we just have to do is to bring the value down here to know our standard deviation, which happens to be 2.62. So representative of grouped figure. Grouped figure. Group data refers to data arranged in classes or intervals. 10 to 19, interval of 9. 20 to 29, interval of 9. 30 to 39, interval of 9. We have the frequency, which is for 6 and 8. This is called a frequency distribution table. Class interval. The class interval is the width of each class. The class interval is the width of each class. Formula. Class interval is equal to upper limit minus the lower limit. What is the upper limit? In each class, we have upper limit, that is within the range of the distribution, and we have the lower limit. In this place, the upper limit of the class 1 with frequency 4 is 19, while the lower limit is 10. So we can choose any of the class to know our class interval. So we're choosing the second class interval, which is 20 to 29. So 29 minus 20 is equal to 9. So class boundary. For us to calculate class boundary, you have to subtract 0.5. Class boundary removes gaps between classes. Class boundary remove gap between classes. So lower boundary, that is 20 minus 0.9, while upper boundary is 29 plus 0.5. That is how we calculate our class boundary. So class boundary is equal to 19.5 minus 29.5, which happens to be 10. Oh, sorry, I didn't write it. You can calculate it yourself. So class mark, which is the midpoint of a class interval formula, have this. So that is it. If you take your time, you browse more, you study more, you try to watch YouTube tutorial on a statistic, particularly on the topic that I just treated, the subtopic, the mean, the media, standard deviation, the mode, the variance, what else? The variance, the range. You try to know more about it. So meet you in the next class. Thank you. So if you have any question, you can just slide into my DM and drop it. I will attend to it later. Thank you.